Generations of computers from history to evolution. Have you ever wondered how computers evolved from room-sized machines to the powerful devices we carry in our pockets? In our last video, we explored the history of computers. We learned how early inventions like the abacus and the analytical engine laid the foundation for the digital world we live in today. Now it's time to look deeper. In this video, we break down the 5 generations of computers, each marked by major technological changes that transformed how computers work and what they can do. Let's begin with the first generation. First generation computers. The first generation of computers began in the 1940s and lasted through the 1950s. These were the earliest true computers that used vacuum tubes to control electrical signals. Vacuum tubes worked like switches that could turn on or off, representing binary data, the ones and zeros. One famous example was the ENIAC, short for Electronic Numerical Integrator in Computer. ENIAC was massive. It filled an entire room, used over 17,000 vacuum tubes, and weighed more than 30 tons. It also consumed huge amounts of electricity and generated a lot of heat, despite its size. First generation computers had very limited memory, no operating systems, and were programmed using machine language, which is the lowest level of code, made up of binary digits. These computers were slow, expensive, and unreliable, but they paved the way for modern computing. Second generation computers. The second generation began in the mid-1950s with the invention of the transistor. Transistors replaced vacuum tubes and had many advantages. They were smaller, faster, cheaper, and more energy efficient. This allowed computers to become more compact and reliable. During this time, companies and government agencies started using computers more widely, not just for research, but for business operations, military use, and scientific work. Another major change was in programming. Instead of just machine language, second-generation computers supported assembly languages, which used symbolic codes. Much easier for humans to write and understand. Computers like the IBM 1401 and UNIVAC 2 became popular during this era. These systems were still large, but much more manageable than their first-generation predecessors. For the first time, computers became tools for data processing, not just calculations. Third generation computers. The third generation arrived in the 1960s and introduced the integrated circuit, also known as the microchip. Instead of using separate transistors, integrated circuits could fit hundreds or even thousands of tiny components onto a single chip of silicon. This innovation made computers even smaller, faster, and more affordable, leading to more widespread use. During this time, computers started to look more like what we use today. They had monitors, keyboards, and operating systems. The idea of multi-programming was introduced, allowing a computer to run more than one task at the same time. Languages like COBOL, Fortran, and BASIC became popular in this era, making programming more accessible. Third-generation computers were used in schools, businesses, and government. It was also during this time that time-sharing systems emerged, allowing multiple users to access a computer at once. Computers were no longer rare or experiment, they were becoming mainstream. Fourth generation computers. The fourth generation began in the 1970s with the invention of the microprocessor. A microprocessor is a complete CPU built on a single chip. It combined all the essential parts, logic, memory, and control into one tiny circuit. This innovation made it possible to create personal computers, or PCs, for everyday use. In 1975, the Altair 8800 became one of the first microprocessor-based computers, sparking interest among hobbyists. A year later, Apple Computer was founded by Steve Jobs and Steve Wozniak, releasing the Apple I and later the Apple II. In 1981, IBM released the IBM PC, using Microsoft's MS-DOS operating system. This launched the PC industry and made computers a common sight in homes and offices. During this generation, we saw major advances, graphical user interfaces, making computers easier to use minds. Printers and storage devices became standard internet access connected users around the world. Laptops and mobile computing became widespread. Software development also exploded during this era, with applications for word processing, gaming, communication, and much more. The fourth generation is still ongoing today, though we're now seeing the early signs of a fifth generation emerging. 5. Fifth generation computing. Fifth generation computers focused on one powerful idea: intelligence. We're no longer just giving computers instructions. Now they are starting to learn, adapt, and even make decisions. This generation is driven by artificial intelligence, or AI systems that can mimic human behavior, like speech recognition, problem solving, and vision. You've probably used fifth generation technology without even realizing it. Voice assistants like Siri, Alexa, and Google Assistant smart home devices that learn your habits, self-driving cars that use real-time sensors and AI models, recommendation systems on YouTube, Netflix, and Spotify. Other areas include robotics, natural language processing, and machine learning, where computers improve themselves over time by analyzing data. We are also seeing the early development of quantum computing, an entirely new way of processing information that uses quantum bits or qubit. Quantum computers are still experimental, but they promise to solve problems far beyond the reach of even today's fastest supercomputers. The fifth generation is still evolving, and as the eye continues to grow, it could reshape how we live, work, and learn. 6. Summary. Comparing the 5 generations. Let's quickly compare the 5 generations. Generation technology, size, speed, features. First, vacuum tubes. Very large, very slow, basic arithmetic. Machine language. Second, transistors, large, faster assembly language. Better reliability. Third, integrated circuits, medium, even faster. Keyboards, OS, multiple users. Fourth, microprocessors. Small, very fast, GUI. Internet, personal computing. Fifth, AI and quantum varies, super fast AI. Robotics, self-learning systems. Each generation built upon the last, and each one brought us closer to the powerful, smart, and connected machines we use today. All through one SCNX, AI sit from vacuum tubes to artificial intelligence. The journey through the generations of computers shows how far we've come and how fast we're still moving. In our next video, we'll explore the main parts of a computer system, including input, output, memory, and storage, and how they all work together. So if you're learning ICT or just love technology, make sure to like, subscribe, and turn on the bell so you don't miss what's coming next. Thanks for watching, and I'll see you in the next one.